So if we look at superposition and quantum entanglement versus the nth ghost theory of time, we come up with some very bizarre conclusions. Um, so let's dig in and find out what those conclusions may be. Superposition is the idea that a quantum particle is in every possible state all at the same exact time, and that state is only defined upon observation. Quantum entanglement states that you have one quantum particle, you cut it in half, and now you have two quantum particles. They are exactly identical, and no matter how far you separate those two identical particles in space, they will always provide the same data when observed from the same angle. I think a lot of scientists say that data is the spin. And then, of course, nth ghost theory of time states that time is not an arbitrary thing that is defined by a clock. It's actually composed of small particles of matter called temporal quanta that fill in the universe in various ways and explain the effects of some of the effects of black holes, how we experience time, the ability to travel through the universe, and the how the Big Bang came to occur. So let's start with superposition. If we look at superposition from the lens of nth ghost theory of time, quantum particles are not in every state at every given point in time and only in a fixed state when observed. In fact, quantum particles operate outside of the effects of temporal quanta, and as such, in their reference point of temporal quanta, they may be moving at a fairly low speed or transitioning from state to state at a fairly low speed. But because they operate outside of the effects of temporal quanta, it would be like humans operating in open space outside of the effects of temporal quanta as defined by nth ghost theory of time and covered in previous videos. Humans would age significantly slower and they would move much, much faster. Things outside of the effects of temporal quanta move much, much faster and age much, much slower. Well, what does that exactly mean? That means that when they're in every single state from our time frame of reference, they're actually not in every single state. It just seems like they are because they're instantaneously transitioning states or transitioning states in such a fast manner that we just believe that they're in every state because we have no way of dissecting time to the degree required to see how they're transitioning, because we do exist within a state of being affected by temporal quanta. And then when we observe them, their state doesn't become fixed. What becomes fixed is our observation of their state. So they're still transitioning. It's just what we observed, that viewpoint or vantage point, has been pulled into our time reference, and that observation has now become static, even though those particles are not static or in a static state. If we move to quantum entanglement, and this is where things get a little bizarre. If you don't think they have already been bizarre, this is where things get a little bit more bizarre. If we look at quantum entanglement from the perspective of nth ghost theory of time, you have a quantum particle that you have essentially cut in half, and now you have two identical particles. And you ship them off to one to the Andromeda Galaxy, and you put the other one on Mars, just for fun. And you look at those two particles from the same angle or same vantage point, and you'll arrive at the same exact data. And that data seems to be random. from how we observe them. Every time you observe those particles from the same angle, you get the same exact data, but that data doesn't follow any pattern that we can discern. It seems to be random. So from Anthko's theory of time, what is actually happening is when you split those quantum particles, what you're actually doing is you are splitting them, but you're also they are also becoming affixed to temporal quanta to account for the missing, for lack of better terms, mass or missing parts. So now you have two quantum particles that are essentially half quantum particles, half temporal particles. And when you send them to different places in the universe, what you're really doing is sending two pieces of time at its most basic unit to two different places in the universe. And time flows in a very potentially flows in a very static manner, and is not at all understood by humans according to Anthko's theory of time, because Anthko's theory of time is extremely theoretical and a little crazy, but not disproven yet. So as we observe these two entangled particles from the same angle, we're only observing the quantum portion of the particles. We're not observing the temporal portion of the particles. And because we're only observing the quantum portion of the particles, their degradation remains the same, because now they are being affected by temporal particles, because they're literally attached to temporal particles. So they're degrading in very much the same way and being influenced by time in very much the same way. So they're not communicating. There is no outside influence, no outside physical influence acting upon them based on previous experiments performed. We know that to be true. And that's how the lens of Anthko's theory of time relates to superposition and quantum entanglement.